So what we have, so what are the types of energy storage? Literally you can see various type of energy storage: mechanical, electromechanical, electrochemical, electrical, chemical, thermal. So based upon, depending upon the application, depending upon the energy usage, depending upon the energy profile, we tend to bring out one of these energy storage. When I say mechanical, so generally the principle of operation would be through mechanical way. Like you have a potential energy, now you have kinetic energy, you convert one form to other, and then in between that you have something known as turbine or pump attached with a electrical generator, which converts the energy, this potential energy to the kinetic energy, then kinetic energy to the electrical energy. On the reverse way, while charging, electrical energy to the kinetic energy, and then kinetic energy to the potential energy. So there are conversion, there are 3-4 stages of conversion, and generally the efficiency of such systems is close to 60-65%. Any of the mechanical energy storage, if you talk about, the end to end energy efficiency would be around 60-65%, 70%, not more than that. What are things comes in mechanical energy storage? Pumped hydro, one of the example, where you have a reservoir at the top, generator at the bottom, again a second reservoir at the bottom. So through the potential energy of the reservoir at the top, you generate the energy through the generator, and then that comes to the bottom reservoir. When you have excess energy available, that time you pump it back to the top reservoir. That's the pumped hydro. Then flywheel. Not only in automotive, wherever you go, flywheel is an important parameter. What does a flywheel do basically? It distributes peaks to the average. In an engine, you have peak powers when the combustion starts. When it goes to BDC, bottom dead center piston, you don't have any energy left there. You have literally zero energy left there. So what a flywheel does, it brings the peak energy and zero energy to the average energy by virtue of its inertia. And same thing happens when you use a large flywheel. It's not large means very big size, large inertia flywheel into this system. So whenever you require, whenever the energy is in excess, it will keep on spinning the flywheel. Whenever energy demand suddenly picks up, at that time it provides the energy. So it's average out the energy taken and energy given by virtue of its inertia. The next comes as a compressed air. We'll talk all the things in detail. The compressed air, when you have an energy available in excess, you compress the air. So basically you are increasing the potential energy. Now whenever you require energy, you allow it to expand, and that time it gives back the energy. Now that can be converted using a generator and a turbine, and when you wanted to compress, at that time you utilize a pump to compress it. So these are the types of the mechanical energy storage devices. Now the second comes electrochemical. One of the prominent electrochemical energy storage devices, lithium ion batteries, which almost everybody is well versed. Those who are thinking about electric vehicle, energy storage, that type of thing. What it does? It takes the energy, convert it into chemical energy, and whenever you require, it gives you back the energy. It takes electrical energy, converts into chemical energy, and gives you back electrical energy. essentially DC. Then you have a flow batteries, or also we say it's redox batteries, flow redox batteries. Similar to lithium ion batteries, but much bigger in the size and the weight. By virtue of reduction of the metal, it generates electricity, and whenever you have excess, you oxidize those metal back. That's how the whole cycle comes into the picture. And then we have fuel cells basically. You can say fuel cells. When we see regenerative, that means it can create the hydrogen when we have energy available, and it will consume the hydrogen to produce the electricity when we have the electricity in demand or energy in demand. The third type comes to electrical energy storage system. What can you think of? Supercapacitors. Basically, capacitor is energy storage device. Since losses are very high, we set supercapacitor. Their losses are much less than the regular capacitors. The another thing which is frequently used in electrical storage is superconducting magnetic energy storage. So here what we do, we store the capacitive energy using the capacitors or supercapacitors. Using superconducting magnetic energy storage, what we do, we store inductive energies. Form is different, but at the end it works out to be an energy storage. Then we have on the chemical side fuel cells. What we talked about here is regenerative fuel cells. Here we are talking about fuel cell. It cannot regenerate. It will take the H2, it will mix with O2, it will become H2O, and then it will give you some energy. Now how to get the H2 becomes separate issues, but if you have H2, then it acts as a very nice energy storage as a fuel cell. It's a converting one energy form to other energy form. Then we have a thermal energy storage. So this thermal energy storage, where by virtue of heat which we can store. How we can store? There are several ways, divided into two: latent heat and sensible heat. So through sensible heat, when we store, like heating the water to or any other substance to 100 degrees centigrade or 99 degrees centigrade, and whenever I need to cook, I will use that same thing for cooking my thing. So it's also act as energy storage. Like here in this room we have air conditioning system. If I'll have a water-based, chilled water-based air conditioning system, I'll continuously chilling the water, sending into the room. There is a heat exchanger which dissipate its heat to that chilled water. It goes back, gets chilled, and come again and keeps on taking the heat from that. Now for the chilled water, what you require? A compressor, refrigeration system, and all those things, which would be continuously running. Now let's suppose if I have a storage where I can keep chilled water for the operation of 4 hours of this room. So whenever I'll have excess electrical energy available, I'll chill the water, I'll keep it stored. Whenever I don't have, I just need to circulate the chilled water here. I don't need to cool the water there, and that portion takes lots of energy. In fact, up to 40% of our commercial building complexes energy goes in the HVAC system, almost half of the energy. And if I have some way to store and run, I can reduce my demand 40% at any given time. I have to worry only about 60%. I'll use other things like mechanical, electrochemical, electrical or chemical energy storage for that 60%, and this 40% I would be using the thermal energy storage. When we talk about latent heat capacity, the energy storage capacity goes 100 times for a thermal energy storage. Like, can I keep ice stored for longer duration? Yes, we can, and it will give me back the chilled water for a much longer time. Similar way, steams. Can I generate steam and keep it stored? Yes, we can do that whenever we require. However, it's slightly difficult task, but it can. So that those type of storage, what we say is thermal energy storage. So let's move one by one to that. I'll try to show you a pictorial representation, its advantage and disadvantage. So what you see here is a pumped hydro. What we have is two storages at the top and the bottom. Now this is the grid, renewable energy grid, which is connected to our household things. Now whenever we have excess energy, at that time we pump back to the reservoir which is at much higher height. So we convert this as a potential energy. Now whenever this grid fails, or we don't have a capacity, sufficient generation capacity, or we don't have the energy available at that time, and we have a turbine and pump combined together, that time this turbine acts as a generator and produce electricity, and which feeds our home. When we have excess energy, this acts as a motor, turns the pump, pushes the water to higher level. Whenever this is not there, it goes back. This motor acts as a generator, this turbine, this pump acts as a turbine and gives back the energy in electrical form to be used in the house. So your house is still running continuously. You don't even feel that what is happening there. So it stores energy by pumping water from the low reservoir to the high level reservoir. The height of the reservoir is made equal to a small hill because you need huge potential energy, and a cavity is made at the bottom to avoid water from running out. There would always be losses because of the vaporization and other thing, but yes, that generally get make up by the rainwater and all those things. Water is pumped during off-peak hours using solar or renewable energy grid, which can have a combination of the energy coming from the wind, coming from the hydroelectric power plant, and wherever there is not much demand, that time this water would be pumped to the reservoir at the higher level. Now whenever you have demand, at that time you generate electricity by running it into turbine and generator mode. So that's about pumped hydro system. Generally it is economical when you go for gigawatt hour storage. At the small level it won't work out, economic doesn't work out well. What are the advantages? It's a very flexible and reliable. It reacts to the network fluctuation in the shortest possible time. You see the same motor and pump can act as a turbine and generator. It just has to reverse the direction. Its reserve output can be utilized when you don't have sufficient renewable to match your demand. It's economically viable only when you put it at the large scale. Initial investment is very high. Plant efficiency can work up to 85%, but when you go the overall efficiency, it would be something between 65 to 75%. Good for water resource management and the flood control. The lifetime is very high, more than 80 years, except that we have to do desilting on regular basis. So the disadvantage is very high initial cost. There could be negative environmental factors wherever you are trying to locate this one. We can eliminate this disadvantage by utilizing only the renewable energy. However, that energy can come from the renewable, non-renewable sources also. So we can ensure that this disadvantage should not come. The next is flywheel energy storage. How does it work? So you have composite flywheels, you have motor generators, the flywheel is attached with that, motor acts as a generator, generator acts as a motor. So whenever you have a power, excess power, this acts as a motor, you keep running this flywheel. Now whenever the energy demand increases or the energy generation reduces, at that time this flywheel make this motor as a generator and gives back you the energy. A lot of technologies has been embedded to reduce the losses, very low frictions, because generally the friction would be very high. So what you require? Bearings, so very low friction bearings. And when I say bearing, it's not only mechanical bearing, sometimes it would be magnetic bearing, sometimes it would be air suspension bearing. So using that, it's ensure that your frictional losses is very low. The second frictional losses comes from because of the rotating surface of the flywheel, and that's getting minimized by creating a vacuum. The whole system would be enclosed in a vacuum chamber, so that you do not have losses because of the air friction. So this is basically a massive cylinder, very high inertia, can go to a RPM up to 1 lakh. Generally will have a magnetic bearings and composite discs, mostly to reduce the frictional losses. All contained in a vacuum chamber. The main aim is to reduce the frictional losses. Low speed FES is also possible, but not as efficient at high speed FES up to 10,000 RPM, and that may have the mechanical bearing, but then your losses would be slightly higher. Also no vacuum, but then your losses would be higher. So electricity powers an electric motors which spins the flywheel, and whenever you require extra power or generation is low, at that time it converts its kinetic energy into the electricity by the motor. The equation is E equal to half j omega square, where j is nothing but flywheel's rotor inertia and omega is its angular velocity, and that is the energy stored in that flywheel. For short term backup, especially frequency regulation, it's a very nice energy storage device. But for longer time, yes, it doesn't work well. For couple of minutes maximum you can utilize this type of energy storage. The another example of flywheel energy storage is like picking up something from using crane. So when you are lifting it up, at that time you require energy, but when it is going down, it can generate the energy. So your overall, so basically you are saying regeneration, and that can increase the system efficiency in much better way. However, it's just for few seconds you can utilize in this way, if you have a few second cycles. What are the advantages? It can provide both high energy and power density for the short. So because of power density, it is mostly used in the frequency stabilization, because power density is very important factor in frequency stabilization. It can reach to the efficiency of 90 to 95%, but you have to employ the much better technique like frictional forces. Whatever is coming, you have to reduce, you have to minimize. How you can do? By using very small frictional bearings like magnetic or air suspension bearing instead of traditional mechanical bearing. Then you have to also worry about air drags, because it's running at very high speed. So by creating a vacuum, by encapsulating this whole system into a vacuum chamber, the air drag can be minimized. There is no absolute vacuum possible, so there would always be some air, but you can reduce the air drag to the great extent by providing the sufficient vacuum. insensitivity to environmental condition. It doesn't matter it's raining or it's a very hot sun or it's a very cold. It can work in any of the situation. There is no chemical involved in this process. That's another good thing. As of now, this technology is very expensive. In future, yes, cost will come down and the utilization would move further. The frictional losses, you always have to worry, and because of that, the cost becomes very high to reduce the frictional losses. Applicable only for very short term, few minutes, not more than that. Let's move next to the compressed air energy storage. What we are talking about is mechanical energy storage. How does it work out? Wherever you have excess energy, you compress the air and put it in one container. Whenever your energy generation is low or demand is more, at that time utilize this compressed air to run the turbine or generator and get the electricity and feed to the demand. So this way is compressed air, other way is the energy generation. When I say burning the fossil fuel, not a desirable option when we are talking about renewable energy. So the second option, whenever I have excess energy available, I will run the pump, compress the air, store it. Whenever energy demand is more or I have a low generation, at that time I generate the electricity and feed to the grid. So it is basically a combination of pure storage plant and power plant. Sometimes power plant can be replaced with the renewable energy sources, but when we are using, let's suppose, thermal energy, thermal power plant, at that time lot of heat goes as the waste. We can increase the efficiency of those plants by utilizing this technology. But when we are talking about renewable energy, we do have a lot of renewable energy. We don't need to use power plant, in fact. So in such cases, it would act as a energy storage only. It works pumping air into the vessel or any cavity which is sealed off and gives back energy to you whenever you require by taking that compressed air from that place. It is considered to be a very low cost energy storage, very low cost energy storage. Whenever you require energy, you expand it through turbine and get back the energy. How does it work? The first one is compression process. Then you store the compressed air, and then expansion process where you take back the energy into, convert energy that compressed air into electricity by the use of a turbine and a generator. The same turbine and generator can act as a motor and pump. How do you compress? If you compress at the lower atmospheric pressure, you won't get much benefit. You have to compress to the very high pressure. So the series of compressor is being used, or turbine would be used to compress the air into the very high pressure, and every compression process the air gets heated. So you have intercooler which keeps on cooling it down to improve the efficiency of the system. Now again you have a waste heat. You can utilize or you can just allow it to escape. During the expansion process, the same compressed air is allowed to expand using the turbine, and by virtue of this, generator rotates, turbine rotates, that rotates the generator, and then you get back the electricity. How do we store the air? It has air storage. It could be above the ground like hydrogen H2, what we say as a tanker, or below the ground when we have salt cavern lot of places, like when we dig when we take out the mining things like coals or something, so you have a big pit and most of the time closed. When you take out the oil, you left a big pit available there. So those things can be utilized. Depleted natural gas cavern, then hard rock, and all those things, these are naturally available to you, which has already been used and now its waste can be used. So you don't have to pay anything for the storage other than the equipment which is going to compress the gas, and that's why it becomes one of the cheapest option. The problem is that efficiency. The efficiency of the system is approximately 60% of the round trip efficiency. So you loses 40% of the energy on the process, and that's what makes it not so economically viable as of today. In future, yes, it can be. Then you also have porous rock beds, from where we get that oils and all those things. What are the advantages? It enhances air quality, significantly lower CO2 emission, because you are not using even if you are using the power plant, you are utilizing all the waste heat together. Renewable energy, there is no CO2. Improved system stability, very low cost of maintenance, because most of the caves what you have found is naturally. You don't have to dig anything for this exactly. Lifetime is very high once you stored, and it's a large, it can give you hours, months energy. If you have a sufficient storage, it can give you the energy back for hours, days and months. Increased energy saving during the off-peak hour demands. The disadvantage, you don't know what is underneath or in that particular cave. You cannot select any site. You have to find wherever this criteria is met, where you have hard rock, where you have already cave formed. Otherwise, if you are going to make it, then it's going to be a very costly affair. Energy conversion loss is quite high in this process. So that's why round trip efficiency comes down to maximum of 60%. And that's not a very good option. I cannot lose 40% of energy in just a process. It may contaminate underground water, may. Not much proof is there, but yes, it can.